And I've set this so that when you enter the Zoom meeting, you're on mute and the video's off, but feel free to turn your video on or unmute. And let me get the chat. So I have the chat on the side, ask questions anytime. Okay. So the main goal for today is to do the syllabus. We'll probably have extra time to do a little bit of notes, but there's no homework this week. Post homework 1 next week on Tuesday. Let's see. Seventh. Okay, so I think we should go through the syllabus first, but if at any time you have questions or concerns, let me know. I have posted it to Canvas, but for now I'm just going to bring it up. And then after that, we'll go through our Canvas setup. Let's see. Going to share. I also forgot to ask, can you guys hear me just fine? It never. Oh, let me see if I can hear you. There we go. Okay, I can hear you. Thank you so much. Okay, sharing the syllabus. All right, we're gonna just hide us for a sec. We're gonna hide the chat. We'll put the chat on the side. Okay. So we are in Math 1, Section 41. It's called Mathematical Reasoning. It's a 3-unit class. To me, this is like a fun math class. We get to do whatever topics we want to do, or I've picked the topics that I'm interested in. There is no math class that comes after this one. This is just going to fill like a general education requirement for math. It doesn't lead you towards your next math class if you need to take another math class. Okay, my full name is Cassandra Walker. I go by Cassie or Professor Walker or anything works. Professor is fine. Email CW2343 is right there. Our class number, so if you need to add the class, you'll need the class number. We meet Tuesday, Thursday, 9 to 10:15. I'm going to record our meetings. If I ever forget, try to remind me to start recording. There's a link to the meeting and our ID. Here's office hour. I'm pretty available this semester, so if you want to meet at another time, sorry, we can make an appointment. But I'll be there every Monday, Wednesday from 1 to 2:30 at this Zoom link or at a different meeting. And by the way, I've set my meetings to just be open, but I'll only be there at these times. So you can sign into the meeting at any time, but I'll be there at the class meeting during 9 to 10, 15, and Monday, Wednesday at usual office hour time unless you talk to me about it. All right, there's no prerequisite for this course. We're going to start with a good foundation, and then I'll just kind of build towards the topics that I like to cover. General education. So this is going to satisfy B4 of general education. So as far as a writing component, what will happen is on your exams, I'll put an essay box. And if there is a, oh, okay, yeah, if you guys are chatting on the side, totally work together. That's cool with me. Or you can work with me, or we can all meet up. Really, we're just trying to get a lot of practice and understanding. Okay, so back to this. On your exams, there's an essay answer response, and if it's a full sentence response, please make it a clear, you know, well thought out response. If you have to just write a math answer, you don't have to show your work, but it can help for me to grade the problem and understand what was going on. Okay, we're kind of going down to class materials. You do not need a book. And we're going to come back to me for a second. So there is a book. It looks like this. It's by Tannenbaum. Let's see. It is a very, not super thick book, but we're only covering like a few little chapters out of this whole thing. And from those chapters, I've picked a few topics and done my own homework and exams and questions. So I'm not even using any questions from the book. I'm just using a couple ideas. We'll talk about them later. So yes, back to the syllabus. I will be making the homework. Let's do screen here. Okay. So you don't have to buy online homework access. You don't have to buy a book. You really don't have to buy anything. You should probably take notes, so maybe get a notebook. But I'm just a fan of note-taking. All right, here's the catalog description. This is for students whose majors do not include a specific mathematics requirement. So if you don't need to take other math classes, and you just need this one math class to check off your general education requirement, then we're going to try to have some fun in this class, and you can stick around working through these 3 topics I picked. Otherwise, you might want to sign up for a different class and kind of build towards that like math goal that you have. Okay, so enhancing skills and vocabulary and focusing on ideas. So as far as that goes, if you ever have any kind of question, let me know. We can put stuff on pause and stop to answer questions, even if it's just about the class or something. I'm here to help. Okay, so this class will be delivered fully through Canvas. We're going to meet on Canvas for Zoom meetings. I'll have the Zoom meetings posted to Canvas. We're going to do assignments using the quiz function. So everything will be labeled quiz, but it'll be sorted into either homework or exams. I plan to do weekly homework, but there's no homework this week. We'll do 3 homeworks for chapter 15, hopefully 3 homeworks for each chapter actually, and then an exam for each chapter. So again, these chapters are from the book, but I've just kind of taken that idea out of the book and done my own thing with it. So one of them is about graphs, charts, numbers. So organizing data. Then there's chapter 16, probability, odds, expectations. So this is using that data and kind of applying some statistics. And then we totally change gears and do something called graph theory, which is chapter 5. It's called the mathematics of getting around. So first 2 topics are sort of related. The 3rd topic you've probably never seen before, but it's really fun. And okay, assignments. There will be weekly homework assignments on Canvas. Homework has multiple choice answers. You have unlimited attempts, no time limit. I mean, you have the week to work on it, but the quiz isn't, the homework quiz isn't timed, and you'll keep the highest score. And if you ever need more time, just let me know. I can always add an extension to your due dates. Okay, exams. There's 3 exams. They're going to be on Canvas. They'll be similar but different to homework. There's 1 for every topic, and your exams have essay answers. So in the essay response box, you'll write your answer. Again, you don't have to show work, but it could help me to grade your problem and maybe give you more points if you show a little work. I've also seen people load a picture of their work. So if you prefer writing your work and you can scan that or post that for me to grade, that's fine. And we're going to have exams during week 6, 11, and 16. So during week 6, we'll have a test on chapter 15. Week 11, a test on chapter 16. And on finals week, your last test on graph theory. And also during finals week or dead week, you can make up any missed assignments or missed exams. So at the end, if you've had trouble during the semester, we can try to make it work during those last 2 weeks. And each exam is its own topic. It's not cumulative. There's no final cumulative exam. All right, so attendance isn't required. It's nice when everyone comes to class, but if only 1 or 2 people, or even if no one comes to class, I'm still going to lecture, I'm still going to record, and I will post the meeting to the modules in Canvas. But again, it's nice when people come and ask questions and ask for more examples and help me to understand what you need to know. Okay, homework. So the Canvas homework is going to be 28% of your grade. Each exam is 24% of your grade. So this is 100% total. And then your grade scale. So at the end, when I have your scores, I'm going to put them through this scale to figure out what your letter grade is. And then at the end, let's see. Cool. There is information that was suggested from the school about resources that are available to you. So there is Students with Disabilities. If you think that you need to contact SSWD for testing accommodations or anything that you need to get through this class or this semester, that's available to you. Or if you have questions about that, just ask me. Student Health and Counseling Services in the Well is really awesome and usually at no cost to you. So they have a lot of programs available, like healthcare, eye care, stuff like that. The last one is CARES. If you're having challenges with food or housing or any other financial challenges this semester, contact CARES. They can try to help. Okay, and then back to class. So I also have information about where to find help with math. I'll try to post like specific info, let's say as an announcement. But there's the math lab. They still have a Zoom what's it called? Option. Okay. I've been contacted by PAL, and I'll share that information. So PAL is peer assisted learning. So people who are interested, like kind of like tutors, but just other students who are working on the same topic you're working on. And I think there's one more. I'm pretty sure it applies to Math 1. It's called Commit to Study. So these are places where you can find help from other students for math, or you can always see me in office hour. So let me try to think about questions I've been asked in the past. So a little bit more about me. I had a great time teaching Math 1 in person. I had packets and we'd get into groups and we'd work out the packets and kind of share our answers and get through the material that way. And last semester, I taught Math 1 online. I thought it went really well. I'm going to use all of that this semester and just add a little extra. And we had exams where you had a week to work on the exam. Do you guys have any questions?
No,
All right.
thank you.
You just bring it up in the chat or let me know. We're going to start taking notes. Starting with chapter 15. Okay, just to kind of stay organized. So starting with sets, a set. So it's a collection of objects called elements. Start sets, start and end with curly brackets. Or, yes, wherever we go. So one of these, and then elements, and then one of those. Okay, the universal set, we use the symbol capital U. It's the set of all elements in consideration. And we'll stick with that. Let's go ahead. What do you need? So the capital U. It's capital U for your universal set. So it's your universe, everything that is possible, like to the problem. All possible elements in your universe. Okay, the empty set is the set that contains no elements. Okay, there's a symbol, it's a circle with a slash. Or it's the set that has nothing in it. Just a comma, or even no comma is fine either way. Just curly brackets, nothing inside. So the set that contains no elements. I want to draw a picture before we keep on doing this called notation. So let's draw our universe. It's usually a square. Just out of like convention or style. If you kind of Google it, your universe looks like this. Label it somewhere on the side or the top, anywhere, maybe on the edge to tell this whole thing is the universe. Something inside, we'll mark with a dot and label it. Let's put some numbers in here. Let's put 2 and 3 and 6. Okay, so those are your elements inside of your universal set. All right, so that makes me think we should talk about a subset and then special subsets. All right, so a subset. So I'm going to use math language to explain this first, but then I'll go back to drawing some pictures and it'll make more sense. So we're going to say that capital A, the set A, is a subset of U. If for every X in A, X is also in U. So we're going to start with U. We'll have a set 1 through 6. U is equal to curly bracket 1, 2, 3, 4, 5, 6. Close your set. There's your full space. We're going to have A be the even numbers. A is 2, 4, 6. So we're going to draw the picture, which is called a Venn diagram. Yeah. Square shape, label it. So I could just throw all these numbers in there and then try to group the evens together, but I'm going to kind of start out with that set, then fill in the rest. So we're going to put A in here, it's a big circle. It contains 2, 4, and 6. If you want to draw a little anchor next to them, like a little dot, like that's 2, and that's 4, and that's 6, you can, or just leave it as numbers. 2, 4, 6. We also need 1, 3, and 5 outside of this set, but still inside of your space. Okay, so A is a subset of U. Every element in A, 2, 4, and 6, are also in U. They're right there. Okay, there are 3 special subsets that we want to cover. The first one is the union of sets. Oh. So we're going to let A and B be sets. A union B. So it's a big U shape, but it's just a swoop, and it's for union. Okay, it's the set. So you start your curly bracket. Okay. We need switches over. It's every X in a, let's see. It's every X in your universe. X in U. Such that, so we go like this. X in U such that X is in A or X is in B. And okay, so I'm thinking that I'm going to flip the whiteboard over in a sec, but if I had a full whiteboard, you want to just put this all in one line, X in A or X in B, but we get it that it's just such that this occurs. Okay. Let's do the other two, and then we'll do examples, and that'll be it for today. So the other one is A intersect B. It's an intersection symbol. It means and. So this is for or, this is for and. Okay, so we're talking about the set of all X in U such that X is in A and X is in B. Last one, it's the complement. It's union, intersection, complement of two sets. So this little symbol is just like the next topic. It's not part of this. This is what we're talking about. And a complement. So that's your complement symbol. It's a C, it's a capital C. For the most part, I'll be writing these symbols, so you don't have to. Well, overall, if you are trying to say something and I understand what you're trying to say, it's fine if it's capital or lowercase. I'm not that picky. What's under the U in red? U is for union. That's, I think, what I wrote. So just, I missed a question earlier. There was this symbol is union. Kind of means or. Then there's that symbol, intersection is for and now we're to complement. So it's all X in U such that X is not in A, it's outside of A. Okay, so examples, and I'm just gonna try to, I have some, I'm gonna try to make up some extra, and then we're good for now. First example has a universal set containing 1 through 5. our subsets. A, the first subset is A, and it contains 1. Then there's a subset B, capital B, contains 4 and 5. Okay, first draw a Venn diagram, then find the intersection, union, and complement. All right, if you guys give me just 1 sec, as a side note, I have 5 cats. I have 1 grumpy cat right now. I'll be right back. Just 1 moment. Hi. Yes. Okay, yeah, we rescued 2 cats over the summer, and we have cat doors, but one of our cats is kind of grumpy and an old guy, so he needs help. Back to doing a Venn diagram. So it's just like a style or habit to have that space, that full space, be a square. Put the U like over here. So that's a capital U, different from union. Your universal set has 1, 2, 3, 4, 5. Let's put a place for A and B first before we do anything else. So we'll put A here, overlap it with B, and then label both. A contains 1, but B does not, so it needs to be here in the set A, but not in circle B. It has to be outside of set B. Cover that. Okay, B contains 4 and 5, but A does not. So don't put those numbers in here. Have them in set B on the side. And go and find a place for all of your other elements, but outside of those sets. So you need to put 2, 3, 4, 5, and we're done. 1, 2, 3, 4, 5. Okay, first, A intersect B. So is this all elements in both A and B? Oh, there's nothing. So this is empty. This is the intersection. This space right here is A intersect B. And in this case, it's the empty set. So you can put curly brackets that are empty, or you can put the 0 with a slash. Or, you know, since we're online and it can be difficult to do symbols, you can write empty set. All right, A union B. So it's this set A along with the set B. So if you wanted to shade it, it would be A shaded and B shaded, both circles covered, which both circles contain 1, 4, and 5. They don't have to be in order. You could put 5, 1, 4, just as long as they're all in that set. And then you close your set. Yes, numbers can be in different sets, just depends on what kind of set you're looking at. So you can repeat these elements in your different sets, depending on like where they live. Let's go on to the complement of, we'll do both. We'll do the complement of A and then we'll do the complement of B. So everything that's not in A. A contained 1, so everything except for 1, which is 2, 3, 4, 5. We're going to find the complement of B. So everything outside of B, which is 1, 2, 3. And then that's a 3, and then that's a curly bracket. All right, I think we're going to go on to a new problem. Any questions or concerns? Alrighty, this time we're going to go into we're going to work with some letters. So our set is capital U. It's a curly bracket, and then the elements are W, X, Y, Z. And again, it's just a what's it called? It's a notation. It's just part of the notation to have the elements be lowercase and the sets be uppercase. Subsets are capital E, and that set contains lowercase w. Your other subset is capital F. It contains a lowercase z. So first, we're going to draw a Venn diagram. Okay, so we have a whole new set. So a whole new picture. Let's make it smaller. Okay. E and F are subsets of U. W is in E, but not F. F only contains C over here. And then you need X and Y somewhere on the sign, but outside of those sets. So we want to get the intersection, the union, and the complement for E and F. So that's right there. It's empty again, so we're going to put an empty set. E union F. So the union, let me see if I have. Let's do orange, would be this set and this set together. So W and C are in the union of E and F. Bracket. Let's get the complement of E. So everything except for W, which would be X, Z, and Y. Okay, so I just erased it, but the set F contains the element Z. So the complement of F is all other elements except for Z. Or you can use your picture. Don't use set F. Get all the other elements from your set. Okay, let's go back to numbers. So I'm thinking we'll do like 2 or 3 more examples, and then that's good for today. So let's do some negative numbers in our universal set. Like this. Universe contains -5, -2, 0. Let's put 4 and 7. And the set A is 0, 4, and 7. Let's put here B. Okay. B is going to contain -2, 4, and 7. I'm going to start with the Venn diagram. So your universe is U. Subsets are A and B. In the set A, you have, well, in every problem, I would check first, do you have common elements between your sets? Because you're going to go right here if you do. So we want to put 4 in this shared space and 7 in that overlapping part between A and B, because it's in both. That's how we represent 4 being in both A and both B, is as long as it's in that part of the picture. -2 is in B, and you've got a 0 in A. And now you need all of the other elements, like -5, we'll put here. -2 is good, 0, 4, 7. Okay, that's the full space. We're going to find subsets of that space. Let's get A intersect B. Okay, so it's that place right there where you have 4 and 7. A union B. Oh, C stands for complement, and it means like, and I'll do like a little abbreviation for everything in a sec. But complement means you're not in that set. So not, the complement of A means not A. So that's what C stands for. And we'll, do that next. Union would be 0, 4, 7, and to -2. They don't have to be in order. They just all have to be in your set. All right, so let's do this. A with a, what's it called, superscript C is A complement or shorthand, you could say the set not A. So okay. So A complement is everything except for elements inside of A. So you want to hide those elements and find everything else, like -5 and -2. Let's see. The complement of B. Let's put it here. So all elements that are not inside of B. So I would just hide those guys, hide everything inside of B, and pick the other elements, 0 and -5. Good morning, sorry. Yes, and by the way, just as a reminder, since it's the first day, I hope to record our meetings. So if you ever miss a meeting or show up late, hopefully you can just catch up with the video. It usually takes me just a day or so to load and post the video. So I'll try to have it up by the next, by their next class meeting or something. Or as soon as possible. I think we're good to go. Let's do another example. And see how we feel after that. So we're going to do another one with letters. The universe is going to be capital U, and it contains A, B, C, D, E. So it's a capital U, lowercase a, b, c. Okay, subsets A. And that contains A, C, E. Let's do the next one down. Let's go down here and put set B contains A, B, E. Let's put A, B, D, E. Okay, so the kinds of questions I ask are mainly about the like the intersection and union and complement, but I think it helps to draw the Venn diagram. So we'll start with a picture and then go through those subsets. Okay, this is capital U. We'll have A and B overlap just in case they share elements, which I'm pretty sure they do. All right, so I would check for common elements first. There's an A common to both, also E. So at this time we have A here and E below. A, E, you also need the element C in your set A. So inside that circle A, put a C, but outside of circle B. Oh, and I got a comment about the meeting. Let me first check my, let me, So I got a comment about the Zoom meeting getting stuck. I have a hotspot that I got from the school, and I should have been on that already. Okay, we're gonna stay here for today, but next time I'll make sure that I log into the connection from school, and it should be a smoother recording. Sorry, I forgot to do that. Well, actually, it'll be a smoother meeting. The meeting can be, what's it called? Stuck sometimes, but the recording should look just fine. So later when I post this, if you go back through it, it should be easy to watch. But yeah, let me know if you ever see it getting blurry or stuck, or if I need to fix something. Let's make this work. Let's get A intersect B first. Oh, actually, I think we need to finish the picture, and then we'll do this. Got A, C, E. We've got A and E. We make B, D over here. All right, A, B, C, D, E. All right, everything's in the space. So the intersection is the set that contains A and E. The union is set A along with set B, and you don't repeat any elements. So it turns out that the union is the full space, but that's just one. A swoop. The complement of A. So this is not in A. It's a set of elements outside of A, which are going to be B and D. Then the complement of B. Yes, B complement. So don't use any elements from B, only that element C. All right, that's set, and what's left over is just a C. Okay, let's see. All right, how do you feel? One more example, or we feel good about sets?
I think I'm understanding the gist of it.
Well, as a teacher, I feel like we should do one more, and then we'll call it. Let's do an easy one. We're going to have our universe be the set that contains 1, 2, 3, 4. So, last one for today. Let's go back to subsets being called E, capital E, and that's going to contain 1, 3, let's put 4. And capital F is another subset, and it contains, let's put 2, 3. All right, picture where we have subsets E, overlap it with F just in case. Look for common elements, like 3 is common to both, so it goes right there where they overlap. There's a 2 in F, but not E. And then there's a 1 and a 4 in E, so inside the circle, but outside of F. There's 1, 2, 3, 4. That takes care of everything in your space. Let's get E union F. So when it's union, like a swoop upward, it means or, E or F. So 1, 3, 4, along with what's in F, 3, 2. You don't need to repeat 3, so just put 1, 3, 2, 4. E intersect F. Looks like this. E and F. Okay, it's that overlapping space. It's just the number 3, or element. The only element in E and F is 3. It's a little hard to read. Complement of E is E, complement sign. Okay, so don't use 1, 3, or 4, so what's left over is 2. complement of F looks like this. It's the set of everything that's not in F. Okay, F has 2 and 3, so don't use 2 and 3. Use 1 and 4. Okay, so that's it for notes today. Again, we don't have to worry about homework right now. I'll post your first homework next week on Tuesday. So please be at the next meeting to continue doing notes, and have a great day.